Okay, let's switch over to one of my favorite topics, testosterone. You had a couple of papers, but I want to tell you a short story on a review paper I co-authored in 1996. How old were you, Katie, in 1996?
10.
Okay, so David, you're quite young as well. But I'm in grad school at the time, and I have a couple friends, and we're just meatheads. We go to the gym, and we're reading. I don't know if you remember the textbook Goodman and Gilman, The Pharmacological Basis of Therapeutic.
Oh, yep.
Yeah. It was I don't know if it is, but it was the Bible of medical school then. I was in grad school. I knew a lot of the medical students and the faculty in the medical school. And going through that, I realized that the section on androgens was just totally wrong. Like, it was just wrong. And we're just three grad students reading it. We're like, these guys have no idea what they're talking about. I'll summarize it. They said that anabolic steroids or androgens cause a whole litany of cancers, cause this, cause that. It doesn't have an ergogenic effect. It doesn't promote the gain in lean body mass. I'm like, wow, these guys are wrong. So we wrote a review paper, published in 1996, Canadian Journal of Applied Physiology. They changed their name after that. And here's the kicker. It was actually rejected by every journal. 7 journals rejected it. And back then, David, you'll get a kick out of this, Katie, it was done by snail mail. There was no email. We had to wait for the damn letter. And I remember, I'm like, we got the 7th rejection. I'm like, nobody wants this paper. But here's the funny part. They didn't reject it based on science. They rejected it based on politics.
I'm not surprised.
Yeah. I'm like, and in fact, it would be in the letter. Well, we agree with your paper. We just can't publish it. So the Canadian Journal of Applied Physiology rejected it. They came back later, like they sent a letter like 3 months later, and they changed their minds like, oh, by the way, I think we're going to publish your paper. The paper basically said this. There are certain androgens you could take, and this is for healthy males. There are certain androgens you can take at certain doses for certain durations, and basically you'll get bigger, faster, stronger without any side effects. That was basically the summary. And then in that same year, Shelley Bassine's group with, what's his name, Tom Storer, they published that paper in 1996, New England Journal of Medicine, testosterone enanthase, 600 milligrams a week for 10 weeks, has no side effects in normal, healthy males. And here's the kicker. Even the guys who didn't exercise got bigger muscles. Yeah. So that's sort of the backdrop. I decided to leave that area as an area of study. Here's why, because nobody gives a shit about data. When it comes to testosterone or androgens, they don't care. They have their minds made up. And that's why when I see studies like this, I'm like, wow, this stuff is really cool. Too bad no one cares. Except me.
Yeah.
Right. So David, that is my little preamble. Tell us a little bit about some of the work you've done, because I think this stuff is cool.
Yeah, you're just getting me in trouble all over the place today, right? Pulse burger, testosterone, we'll solve it all. But I was to be fair, I was a small part of this one. My the lead author is Alyssa Varanovsky, and she directed the project under Stefan Pasiakos direction, and Arny and I played. Arny was I think a co-I with Stefan on that, but we played our small role in it. But Alyssa, ironically, was right behind me in my PhD, so we had the same mentor and advisee team at the University of Central Florida. So it was kind of fun to get an extra 2 years of working with her, and she's at NASA doing cool stuff now. So
who was your PhD advisor again? Who was it again?
I was at UCF with Dr. Hoffman and Dr. Stout, Dr. Fukuda, and Matt Stock. It was kind of a team committee, so to speak, approach down there. But so Alyssa was right behind me, so she's the lead author, and I have a paper coming from it too, where we have the muscle protein kinetics in it, but she kind of has like what you were talking about earlier about what really matters in terms of the performance and the function. And we did it at Pennington Biomedical Research Center, and I say that because for like listeners that don't know, it's like the gold standard inpatient studies. Like, it's a super core facility. I got to go down there and see it, and it's incredible, and everything is controlled. So there's 3 phases of the study. Phase 1 was kind of like the run-in where we did all their baseline testing, their free living. And phase 2, we did this is when they went to Pennington full-time, and they're inpatient for 21 days. And then there was a phase 3 where it's kind of like at home recovery, ad libitum, on your own. So the point is during phase 2, right, that was completely controlled, like as much as it could be, like sleep, food they're getting, activity, constantly being monitored, et cetera. I mean, it's an amazing study in that regard. And what we did was, like I said, there's phase 1 where we got all their baseline measures, performance measures, body comp. We did the muscle protein synthesis and breakdown, and then we did whole body synthesis and breakdown. And we only did the muscle side in the basal state and the rested state, and that's fine with testosterone because that seems to be where it works. Doesn't really seem to work with the feeding aspect. So we did that all, and then once they got to Pennington, we started that phase 2 period. That was like to simulate sustained operation. And they really beat these people up. It was all males for obvious reasons. And the backdrop of it is if you look at the data, generally speaking, at these large energy deficits, sleep restriction, high energy expenditure, all that, and you look at Brad Nindle's work right from the Army Ranger training, they all become hypogonadal. So the important thing is we were trying to see if we could replace it. Now,
You say they all become hypogonadal?
if you look at like Brad Nindle's work,
Yeah.
and if you look in this study, there's the average for sure is hypogonadal. And I believe in Brad Nindle's work with the Ranger training, I believe I think they all became hypogonadal. I don't think he had anyone that was in normal range.
It's crazy.
Yeah, and so the point is like even in apparently young healthy men, you make the stress load, the catabolic stress load high enough, they'll become hypogonadal. So the idea is, well, can we just replace what they're lost, do testosterone replacement therapy, and have them be better operators, right? Better soldiers. And so during that inpatient period, it was prescribed a 55% energy deficit diet, which I believe the lowest we usually see is about 40%, and you're able to maintain muscle mass. So we were well past that. 55% is pretty aggressive. And then on top of that, if that wasn't enough, every 2 nights, so like, night 1, night 2, you get normal sleep, and night 3 and night 4 and night 5, so 3 nights in a row, you would get sleep restriction for 4 hours.
So they're underslept, underfed.
Underslept, underfed, overworked.
Oh, God.
Because they're also, they're out on rucks, and so it's the exercise and diet induced energy deficit of we were aiming for 55%. And so yeah, we did that for like 20 days, 21 days. And then at the end of that, we assessed, all the performance metrics, all the fancy isotope work, this, that, and the other. And then they got another 20 so days free living and assessed it all at the end to kind of simulate like they go out on a mission, right? And they do these repeated military missions while they're out, and they come back and they're recovering, eating what they want to eat. We didn't control their food or anything. Generally speaking, what we saw was that the testosterone group held on to fat-free mass and lean body mass better than the placebo group. And interestingly, body mass loss was similar between the groups, but the placebo group lost more of it as muscle, whereas the testosterone group lost more of it as fat. And that was mirrored by the protein kinetics. We saw that the testosterone group had significantly reduced muscle protein breakdown in the basal state as compared to the group that got the placebo injection. And so that probably explains what we saw, the preservation of fat-free mass and lean body mass was this improvement in muscle protein kinetics. But at the end of the day, what mattered was kind of the functional parameters, and we didn't see any improvements in the functional parameters like a 3-arm deadlift, VO2 testing, ruck march time, like pragmatic military outcomes. And we didn't see any improvements or any sustainment of those performance metrics in the testosterone group as compared to placebo. So,
What was the dose of testosterone? This was testananthate?
Oh, yeah, it's testosterone undecanate, because the idea is it's got like a 12-week half-life, so you could single injection, 750 mgs. So
700 mgs to cover how many weeks?
It was 21 days, so 3 weeks.
That's not a bad dose. It's not a lot.
No, it's not a lot. Remember, the idea was testosterone replacement. And I'm trying to remember, I remember that during the actual phase 2, that inpatient period, when we were really beating them up, I remember total testosterone concentrations in the group that got testosterone were significantly elevated over their resting state. So it maintained testosterone concentrations.
Would you happen to know off the top of your head what the T levels were on the group getting the placebo, how low it got?
I
And
don't
they were
know.
hypogonadal, right? So
I don't know off the top of my head. I remember when I talked to, I'm trying to remember because we measured free in total, and this
Right.
sounds bad. You can't remember your own publications, but it's always one of these things. You write the grant, and then you wait, and you get the study, and then you do the study, and then by the time you write the paper, it's like, well, it's been a year since we've done the study. So I can't remember off the top of my head if that placebo group got hypogonadal or not. But that would be a reasonable explanation.
So Katie, what dose of testosterone do you take? Did you tell the audience?
Well, it depends. I might join your study. I don't know what I'm going to get. Am I going to get the testosterone booster? Am I going to get the placebo?
Yeah, it's kind of what Arny and I always said. Like, if you're going to do that study, what group did you want to be in? Well, you want to be the testosterone group.
Absolutely. But then, I mean, how do I can't break the blind, but
Yeah, that's the problem.
And also, I'm sorry, Dave, you've done some work looking at testosterone and cognitive function as well?
Some, but we've done it in terms of like, we found that like bioavailable testosterone seems to be related to these various domains of cognition in older men, and that was like an in-Haines like analysis. But with some of the more interesting work that we're trying to work on is like testosterone normalization and recovery. That seems to be the more interesting thing. So if you look at like individuals that get MTBI, they obviously have cognitive impairments, but they also, a large portion of them become hypogonadal. I forget the number, but it's like 30 or 40% become hypogonadal, which is something you don't ever think about, right? You're always thinking about the head, but they become hypogonadal. And there's studies that actually, will look at, the use of testosterone in these patients. So it's not like we're doing anything completely new, but one of the things we've seen in rodent models is that these blast injuries, if you use an actual like TNC analog versus a lot will use like a hammer on the head of these rodents, which is a much different impact than like
I've seen that model. It's crazy.
It's crazy. And I know of a researcher that tries to do a similar thing in humans where they're looking at MTBI and they launch like soccer balls out. And I was like, you got that through an IRB. So, there's different ways of doing it, but it's not.
Yes, I remember reading that to at least mimic what happens in a soccer game.
Yeah. I don't know if I'd sign up for that study, but I mean, the point being is that, on top of that, all that sequelae I mentioned, if you look at Dr. Elizabeth Borsheim, who did her postdoc with Barney, there we go. That's what I'm starting calling him, Bob and Arny. She looked at plasma essential amino acid concentrations after ingesting, oral essential amino acids in individuals that had mild TBI, and they have a lower essential amino acid response to this crystalline amino acid ingestion. So they're showing signs of not only being hypogonadal, but being a little bit anabolically insensitive to nutrition. So you kind of got the worst of both worlds there. So we're trying to go down that path and seeing if we can normalize testosterone. Can that, maintain the signal to the machinery in the muscle in order to maintain muscle mass and quality of life and get this TBI. And then it does seem like the testo might, in fact, make them more resilient from a cognitive standpoint as well, but that's not near as.
Would it make women more resilient if they engage in sports like MMA, soccer, and they get TBI?
I have no clue. I mean, I did a lot of BDNF work in my PhD, and it's really interesting that testosterone and estrogen seem to have like pretty prominent roles on how that all plays out with BDNF. And by the way, in MTBI patients, you see lower plasma BDNF values, but I would caution people from over-interpreting BDNF in the blood because there's a lot going on there. But I don't have the slightest idea how it react in women. Yeah, that's a good question.
What Katie and I are gonna do, I'm gonna throw soccer balls at her head, and she's gonna take some anabolic steroids, and we're gonna do our own case study, right? Right, Katie? We'll start tomorrow.
I'm in. Yeah, we we'll do some cognitive tests as well, different areas of the brain.
Yeah.
Test BDNF as well. I'm use me as a lab rat. I'm all for learning.
Yeah, because that might be an area where you see a true like sex-based difference. Is that maybe the
Absolutely.
estrogen's more protective in women and testosterone's more protective in men or something? But
Yeah.
yeah, I because clinically I can't give testosterone to women, so I only ever think when I'm thinking in the context of testosterone, these things is okay. Well, I got to find something that's predominantly like that can be used in men. Yeah, I honestly hadn't that angle. I know what it'll do to the muscle in a woman.
Well,
I
so
don't know.
I started to read your paper and I didn't get very far into it.
Me either.
Abstract was read and the introduction was read. But the one where you're talking about the cognitive areas that you tested with testosterone, I think there was like 5 different tests and only one showed back that it was significant. I was trying to pull it up. I must have deleted it on accident, but do you remember which one was significant versus the other ones? And do you know which area of the brain? Because you know, like some of these cognitive tests are really focused on the hippocampus. So it's like the learning and memory center of the brain. I'm just trying to pinpoint maybe testosterone is going to a particular place working since not all of them came back significant. Do you know where I'm going with this?
Oh, here it
Yeah,
is.
I know
The
what you're
digit
talking.
symbol substitution test, the DSST. I don't know what the hell that is.
Yeah,
I'm not familiar with that one either.
yeah. I almost forget what that is, but my knee jerk would don't. Your listeners do not take this with anything more than a grain of salt. But my guess is it'd be some type of hippocampus-based memory.
That's what I feel like. I feel like most of the studies that when you use a cognitive test that come out significant tend to be that learning and memory center. Maybe it's just because, it's quick recall and memorization and things like that. But I was just curious.
It might just be a more sensitive test to be fair. Like we would find reaction time to be pretty sensitive. So it might be something more to do with the test rather than the treatment per se. Like it might just be there's greater power with that test. So it's not that the effect of testosterone that exists in these other domains of cognition, like executive function. It's just you'd need a larger N size to maybe see it. Because if you looked at that study for like an epidemiological study, it was fairly low N size, I believe. I don't think they usually have like thousands of people. We had under 1,000 in that for sure.
Yeah.
Hey, we're a little short on time. I want you to comment real quickly on the study. And actually, I found it semi-fascinating. The impact of Hayward green kiwi fruit, because I like kiwi fruit, on dietary protein digestion and protein metabolism. Like, let's see, who is the lead author is Sang-Hee Park, and I guess Robert Wolfe Sr.
Yeah.
Why kiwi? Why?
That was my question. Why kiwi?
Yeah, well, it has like a compound in it that helps break down like peptide bonds, like that whole shtick, right? And so yeah, hydrogenase or whatever. I forget. It's like it starts with an A. I'm trying to remember the exact compound that kiwis have in it, but like first off, there's a company that sells kiwis that was, I think, interested in funding the study. So I was a postdoc when this happened, and this was already like, I think, funded by the time I came on.
Oh, here it is, David. I've never heard of it. Actinidin protease. Actinidin?
Yeah, I was close. I'll take it. Actinidin. Yeah, I remember that. And pineapple has them too, right?
Oh, okay.
So, yeah, pineapple has like cysteine peptidases and stuff where it'll break down the cysteine bonds. But yeah, it has that compound in it where it seems to help break down these protein bonds, and you maybe get better bioavailability, right? Was the idea. And so what's cool is that compound's available in green kiwi fruits, but it's not in gold kiwi fruits. So it made like a nice way to do a comparison. And long story short is that it didn't really affect anything at the muscle level, but we did see improvements in like the rate of appearance of phenylalanine. So the green kiwis had a quicker appearance of phenylalanine into the blood as compared to the gold. But I believe over the entire 5-hour period, ended up being a pretty similar kinetic response between the two treatments. So it was a cool study. It was kind of like, fair warning to the reviewers, it was kind of contrived because they had to eat like 4 kiwis a day for 2 weeks and then come into the study, and you eat the beef with the kiwi. So if we'd have saw something, the translation would have been, yeah, if you eat kiwis every day, you get an enhanced response.
That's where I was going with that. Post-exercise kiwi with your chicken or beef in this case.
Yeah, I mean, if you want to. not a bad source of, it's not a bad source of carbohydrates, you know.
Hey, I want to let the audience know that they can find you on Twitter. They can like harass you, Dr. Myohead, just so you know.
Please don't.
Dr. Myohead.
Yeah.
Tell the audience what projects you have going on now. Hopefully we'll hear about some of this cool stuff next year at ISSN.
Yeah, so I'm trying to write that paper. Arny's always on me about writing quicker. So if anyone's got any secrets, share with me on Twitter. So I'm writing up the paper for the Impossible Burger. I'm actually writing another paper about how the cessation of testosterone. The animals were given testosterone early in life, and then they were allowed to age, and they were given testosterone again for like 7 months, which I forget my math. That's like 40 some years in a human, or 20 some years in a human. And then we measured their rates of muscle protein synthesis after that. And then in terms of what's going on in the lab right now, we have some time restricted feeding studies going on, and looking at protein kinetics with time restricted feeding. And I did like the 6 versus 18. I have one in review where we did kind of like, it ended up being 8.5 just because of how long it takes older people to eat food. But it was kind of like 8 versus 16. But we didn't have a normal diet comparator. But anyway, this study does. So we'll have a time restricted feeding group, different amount of protein, and then all that compared to like a regular dietary pattern. And then trying to get some stuff going in head and neck cancer. So really clinical based ameliorating of stress states.
Ameliorating. Katie, do you have any final thoughts or words for Dr. David Church?
No, thanks for doing some really cool research. I love going to ISSN and hearing all the new things that you come up with. I am hoping to do research with you and Arny, but
Yeah, email Arny. Email Arny. He's got a little bit more time than me right now.
Well, Dr. Church, I want to thank you for appearing on Sports Science News. I want to thank Katie for filling in as co-host for Tony Ricci. The podcast will be on YouTube, Spotify, also on Rumble and Apple Podcasts. So give it a couple of days, David. I'll make sure I tag you, and I'll come up with some really cool tags so that everyone will like send you emails and whatnot. And I'll get all the vegans to send you emails especially.
Thank you.